This is the last part of our video on algebraic vectors, and we are going to be calculating the magnitude and direction of some vectors. And we're going to try using a couple of different methods, and then you are always welcome to pick the method that you like the best. So we're going to start with vector A, which is the easiest of the three. And I say that because it follows one of my grid lines. So if I wanted to calculate the magnitude and the direction, I actually can just count out the magnitude because it's just sitting on one of my grid lines. If I were looking at vector A, I notice from tail to head, it is 1, 2, 3, 4, 5, 6 squares long. Or I would call that 6 units. So down here at the bottom, I'm going to say that vector A is 6 units long. That is the magnitude. And then for the direction, there is a compass over here on the side. This vector is pointing to the right. So I could write 6 units to the right, or I'm going to write 6 units east. So I always put my direction in a square bracket. So I'm going to say that it's 6 units east. If it didn't have the north, south, east, west marking on the page, I probably would have written just left, but it is easier when we have diagonal lines if we're dealing with north, south, east, and west. All right, well, that was vector A. For vector B, you'll notice this one is on an angle, so I can't just count out the length. But what I could do is make a little triangle between the tail and the head. And that little triangle is going to be a right angle triangle. This side is 1, 2, 3, 4, 5, 6 squares or 6 units long. And this side is 2 squares or 2 units long. Now, if I have 2 sides in a right angle triangle and I want to find the length of the third side, I can use Pythagorean Theorem. So to do vector B, I'm going to start by using Pythagorean Theorem to calculate the length of that vector or the magnitude of the vector. So when I'm doing Pythagorean Theorem, I use A, B, and C, which is confusing given we have vector A, vector B, and vector C. So I might use uppercase letters here. The hypotenuse is always the largest side across from the right angle. So that's this one here, that's C. And then A and B are my other 2 sides, and it really doesn't matter which one is which. So I'm going to let that one be A and this one be B. All right, so if I do A squared plus B squared equals C squared, which is what Pythagorean Theorem is, that means 2 squared plus 6 squared equals C squared, or the magnitude of B, which I probably should have written in, and I will write that on the next line, just so you can see what that notation looks like. Actually, I can turn that C into a B. Here we go. So I'm going to call that the magnitude. That's those lines. Remember, those are the absolute value lines that we put around vector B. Okay, 2 squared is 4. 6 squared is 36. And then that's the magnitude of B squared. That's just notation. And then I'm going to add 36 and 4. So 36 plus 4 is 40. That's the magnitude of B squared. Now, depending on the question, I might leave it. Sorry, we haven't done the next step yet. So to get rid of the square, I would need to square root. Now, we have talked about how when you change a square into a square root, we do get a positive and a negative answer. And I could write plus and minus, but I would need to throw away the negative since you can't have less than, you can't measure something that's less than 0. So I am going to ignore the negative just because with Pythagorean Theorem it doesn't make sense to get the negative, but I could put it in and then just throw away the negative value. So when I do the square root of 40, sorry, I'm getting a little weird pop-up on my computer. When I do the square root of 40, that is a decimal. And I just need my calculator. Hold on one second. So if I do the square root of 40, I get this. And it didn't mention anything about rounding, so I think I would like to leave it as an exact value. So I could just leave it as the square root of 40, but what would be the fun in that? Something that we learned how to do way back was how to write a mixed radical. That would have been something we did in grade 11. I would look for the largest perfect square that goes into 40, and I'm pretty sure that would be 4. So 40 is 4 times 10. 4 is a perfect square. 10 is not. So I'm going to say that the magnitude of B is the square root of 4 times the square root of 10. Square root of 4 is 2. Square root of 10 is a decimal, so I'm going to leave it as 2 times the square root of 10. So I now know that the magnitude of B, or the length of B, is 2 times the square root of 10. Okay. The next thing I need to do is the direction that goes with it. So in order to find the direction that goes with it, I want to try to look for the tail of the vector. So where does the vector start? Because when I was drawing my vectors up here, we started at the origin, right? And then we measured our angle from there. So I always want to try to figure out the direction from the tail of the vector. And I'm going to just try to draw in a little north, south, east, west axis here to help me out. So this vector is closest to the north. We usually start with north and then go east, or north and then go west. We don't often start east and then go from there. But if I wanted to know this angle up here, that's not inside my triangle. So I'm thinking I probably am going to find this angle right here inside that triangle instead. So to find that angle, we are going to have to use some trigonometry. I might just call it X. I don't think you're going to be able to see it. It's really tiny. Just trust me, it's an X. All right, so to find that X, I am going to use a trig ratio. So I would either use sine, cosine, or tan, depending on the angles and the information I have. So based on this angle, this side over here is my opposite. I'm running out of colors to label with here. This is my opposite. The hypotenuse is this one here. And then that would make this the adjacent. So what I would like to do, I know in the question I was given the 2 and the 6, which is opposite and adjacent, so I would probably use tan. I could use the hypotenuse because I have calculated that, but I might have made a mistake. So I like to just use the sides that I was given in the question if I can, which are the 2 and the 6. So I probably would use the tan ratio for this. So I'm going to say that tan of X is opposite over adjacent. So tan of, I don't know what X is, that's the whole point of this, is opposite 2 over adjacent 6. 2 over 6 does reduce to 1/3. And you'll be happy to know that I'm not going to make you do this as an exact value. We're actually going to use our calculator. So I am going to do the inverse tan of 1/3. And I'm not going to worry about what quadrant it's in because I know that it's just a tiny little angle here that would be in quadrant 1 because it's less than 90 degrees or it's less than pi over 2. So I'm not going to stress about thinking about different quadrants. We're just going to do that calculation on our calculator. I am going to make sure that I am in degrees. So the inverse tan of 1/3. On my calculator, I have to do the 1 divided by 3 first, and then my inverse tan, and I get approximately 18.43 degrees. Okay, so based on the way this vector is drawn, its magnitude is 2√10, and its angle at 18.43 degrees is measured from east. So I could say east and then 18.43 degrees north. So I could say that vector B is 2 root 10. And then east, 18.43 degrees north, because we started with the angle going east and then we're pushing it up towards the north. Or you could take this angle and subtract from 90 degrees so that you could do north and then whatever that resulting angle is, and then to the east from there. So I'm going to just figure out what that is. If I subtract from 90, I get 71.57 degrees. So I could say B is 2 root 10 north, 71.57 degrees east. Right, so it's the same angle, it's just whether I'm measuring it from the east going up or whether I'm measuring it from the north and coming down. Okay, we are going to have to do vector C in the last part of the video because I don't think I have enough time left for me to post this. All right, I will see you in the next video to finish off that last calculation.